Hi there, Dan Westgate from Brilliant Ideas, and in this explainer video I'll be talking about powered access machines, and in this particular video MUPs, and how the load from the MUP is going into the ground, and is ground improvement or load spread required, which would also depend on the ground conditions. Now, one of the things that we find when we're looking at an ALIMATS solution to spread load from powered access is the material available from data sheets from hire companies. It's actually quite simple what we're looking for. For example, we would always need the wheelbase to understand the distance between the wheels, and we'd also need the track width. Now, on the data sheets, the track width is sometimes specified as the width, but that's outside to outside of the wheel, not centre to centre, which is what we need. And also, very rarely do we actually get the contact area of the wheel onto the ground, and the maximum load applied is expressed sometimes as kgs per centimetre squared, which we don't believe that is an overly relatable value, and we actually believe it should just be expressed as maximum force in kilonewtons or maximum load in tonnes with regards the maximum load going through one of these wheels. It's really important that the load going through these machines is understood. The type of tyre is very relevant. For example, nylon tyres are a lot harder than rubber tyres, and the subsequent, you're actually getting less contact with the ground, and you actually get an increased pressure. And also the tread's very relevant as well. As you can see from the treads with this particular tyre, you've got a high concentration of load due to that profile. There's two load cases. One of the load cases is the tracking condition, where it's just tracking along and the boom is not extended at all. And then the second load case is the operating condition, when the boom could be out at full reach and you're going to get a maximum load over one wheel. The machine we're looking at here weighs just over 10 tonnes, and that depends on whether or not it's foam filled or air filled wheels. Based on our standard approach to working out the maximum wheel load, which would be 60% of the gross weight of the machine plus the basket capacity, would actually give a maximum wheel load from 6.3 tonnes to 6.7 tonnes, depending on the type of wheels. And we think if the data sheets were expressing the maximum wheel load in the operating condition in such a way, that would be a lot more relatable, and subsequently be a lot simpler to understand on whether or not a load spread or a ground improvement system or solution was required. Okay, so what I'm standing in front of here is one of our tracking solutions, where we've utilised our 3.48 long handleable interlocking aluminium modules titled ALIMATS. So these modules are 3.48 long by 0.29 wide, and they are 60mm deep, and they are a different profile to our standard module, which is 580 wide. It's actually quite a chunkier section. What we can also adopt this system for, to reduce the number of mats, is we can actually use this as a rolling road. So you're actually picking from behind and placing in front as a machine tracks. And the reason why they've been placed at an angle, that's to reduce a rippling effect, which can be caused from when the MUP actually tracks over it, and it also enhances its ability to spread the load. The load from the tracking is going perpendicular across the interlock, and as they're at an angle, that is going across multiple modules. So this is just a single layer for the tracking condition to assist with load spread. And when we get to the end of the track, we'll actually put an additional layer of mats down to enhance the load spread. So when the MUP is actually operating, it would be working very similar to our crane outrigger mats that we would adopt under mobile cranes. Okay, so we're at the end of the track system here, the single layer of ALIMATS. So we're just going to show the simplicity of how we put them down. You'll notice in the background we've got the white ether foam, and that's a compressible layer that we would always recommend when setting up on hard surfaces like concrete or tarmac. And the reason why you need a compressible layer is because if the mat isn't deflecting, it's essentially not spreading load. It would simply just be transferring the load through the wheel of the MUP straight through the mat itself, onto the concrete that you can see on this yard. One of the benefits this system has over track systems that are not handleable is that you can carry these into restricted areas around the side of buildings where you wouldn't be able to get the necessary plant to install a unhandleable track system. And there we have it. So that's the end of the track ready to receive the mute to track down. Okay, so what we're doing here is we're putting an extra layer of modules down. The MUPE is in position. We've already put the single module down to the wheel that's out of shot of camera. And the purpose of doing this with providing 2 layers is getting an increased load spread, and it would operate very similar to how our standard configurations work under mobile cranes. The area of load spread is obviously dependent on the spread required, and as you can see, for the purpose of this video, it's not an enormous load spread due to the track width not being that great. However, should a greater load spread be required, you could put a double track down or a wider track and also put more than a single module on the top layer. But with this 2-layer system, you do get full load spread below the mat surface.